Section 5.1, Angles of Triangles. We have some vocabulary here, quite a bit on Section 5.1. The first word is scalene triangle. It is a triangle with three different side lengths. So maybe this is a 5, this is a 2, and this is a 6. Three different number side lengths. Isosceles is a triangle with two or more equal sides. So maybe this is a 5, this is a 5, and this is a 6, is isosceles. Now technically it's 2 or more, but when it has more than two equal sides, we typically call it an equilateral triangle, and that is when all three side lengths are exactly the same, 5, 5, and 5. Now although I chose numbers here, a faster way to do it is congruent marks on all three here. For the isosceles, two congruent marks, or congruent marks on two of the sides, but the third side would not typically have one. An acute triangle is a triangle with three acute angles. It's typically going to look more like this, where all three angles are less than 90 degrees. A right triangle is a triangle with one 90-degree angle. One 90-degree angle, and an obtuse triangle is a triangle with one obtuse angle. Maybe it'll look more like this. Now all three options, acute, right, and obtuse, can be scalene, isosceles, or equilateral. It just kind of depends on the scenario. So equiangular triangle is a triangle with three equal congruent angles. So it might look like this. Congruent marks on all three sets of angles. Interior angles are angles that are inside the polygon, or inside, in this case, a triangle. So the interior angles would be 3 on the inside. And an exterior angle is an angle on the outside. And the problem is that right now the triangle itself doesn't have any angles on the outside. It has an outside, but it doesn't have any angles. So typically what it's going to be, I call it a triangle with a tail, and that is an exterior angle. Now if you draw, let's see here, maybe a hexagon. All polygons could have exterior angles. In a hexagon, it would look more like this. You could have 6 exterior angles, and these are the exterior angles. Kind of looks like a pinwheel, one of those like little toys that you blow on and they spin real fast in a circle. Typically in this section we think of it, I call it a triangle with a tail. Go straight off from one of the edges, that's the exterior. Now the triangle sum theorem, one of the most important things of geometry first semester, is that the inside of an angle must add up to 180 degrees. So for example, if you have a 90-degree triangle and this angle is 40, this angle up here must be 50, because 40 plus 50 plus 90 equals 180. And the triangle sum theorem is the reason, for example, an obtuse angle can only have one obtuse angle. So let's say this angle here was 100 degrees. Well, this one can't also be 100 because then they won't add up to 180. So this rule right here, the triangle sum theorem, is why, another example, the right triangle can only have one 90-degree angle, because if there were two 90-degree angles, then the third angle would have to be 0, and that's not possible. The exterior angle theorem says if you have a triangle with a tail, let's say this one was 100 degrees, the exterior angle is equal to the sum of the two non-adjacent interior angles. Adjacent means next to, so it's the two angles that are not next to the 100. So let's say if this was 60, that would have to be 40, because 60 plus 40 equals 100. The last thing, the corollary to the triangle sum theorem. If you have a 90-degree triangle, these two angles here must add to 90. And the reason for that is because all three angles have to add up to 180. This one is already 90, so 180 minus 90 is 90, means these two must add up to 90 also. All right, let's look at example 1. Classify the triangle by its sides and, if necessary, by measuring its angles. And you should include two names for each. So we need to classify it off of the side lengths. Is it scalene, isosceles, or equilateral? And then on the angles, is it acute, right, or obtuse? So let's look at this first triangle. Do these side lengths, do any of them look the same? To me, they all look different, which is called scalene. What about the angles? Do any of the angles look like they are more than 90 degrees? Now, if you can't tell, you're not sure, grab here a piece of mail off my table. Compare the corner of the paper, which is 90 degrees, to the corner of the triangle. Do you see this? This angle, angle Q, is bigger than the 90-degree corner of the paper. Angle R is smaller, and angle P is smaller. But we do have angle Q, which is obtuse. So we call this triangle an obtuse scalene triangle. Now looking at the second triangle here, all three side lengths look different to me. AB is the longest. So let's see about corner, B is less than 90, A is less than 90. We just got to check angle C. So you put your piece of paper, the corner of your paper, right in there. And you see how it's like almost perfect? That's a 90-degree angle right there. So this is a right scalene. Third triangle. Right here, do you see those tick marks? That means that those two side lengths are the same. This is isosceles. And EFG, they all look to be less than 90 degrees. So this is an acute isosceles triangle. When you classify means to name. You need one about side lengths and one about angles. Takes two names. Example 2, find the measure of the exterior angle. Exterior is the outside, and just like here, we said the outside was equal to the sum of the two inside. So the outside is equal to the sum of the two inside. Which angle is outside? That's angle 1. Let's call that maybe an X, so it's easier to talk about. Is equal to the sum of the two inside. Now, not the one next to X, but the other two. 53 and 53. So X would be 106 degrees. Example 3. Find the measure of the exterior angle. Again, the outside is equal to the sum of the two inside. The difference here is that these are more complicated. So your outside angle So right here, the 8x minus 5 is equal to the sum of the two inside ones. Well, 40 is one of the inside ones, and the other one is 5x plus 15. So 8x minus 5 equals, combine like terms, the 40, or simplify, the 40 and the 15 is 55 plus 5x. From here on out, the geometry is essentially done. We just need to solve for x. So I'm going to subtract 5x from both sides. 3x minus 5 equals 55. Add 5. 3x equals 60. Divide by 3. You get x equals 20. Now, very often I lose sight along the way. I get excited because I know the formula, I know how to do the algebra. Lo and behold, I get to the end and I actually don't go back to verify. Read the question. Find the measure of the exterior angle. I found x. We need to now actually find the angle measure. And we do that by plugging it in. 8 times 20 minus 5. We're plugging it into the exterior angle because that's the one we're looking for here in the directions. So 160 minus 5 is 155 degrees. All right, example 4. In a right triangle, the measure of one acute angle is twice the sum of the other acute angle and 30. Find the measure of each acute angle. Now, example 4 causes a lot of fear sometimes because this is a story problem, kind of. It doesn't have a picture. So the best thing to do is to make a picture. Right? If you don't have a picture and you want a picture, make a picture, draw one. It's a right triangle, so we know it has one 90-degree angle. Now after that, we kind of just have to take a guess here. One of these angles, when you don't know something in math, you typically put an X. So I'm going to put an X, and I'm going to put it at the top one, quite honestly, because it just looks smaller. I don't want to put anything else in this one because it's a skinnier angle. In the fatter angle, I'm going to deal with the fact that this angle is twice the sum of the other acute angle and 30. So twice means times 2. Sum means add. And what do we add? We add the other acute angle. The other acute angle is x and 30. So this angle down here, there's the x plus 30, but it's twice. So it's 2 times the quantity x plus 30. Now for me, once I have a picture drawn like this, I know that the angles of a triangle add up to 180 degrees. And I would probably just go right ahead. 90 plus x plus 2 times x plus 30 equals 180. Now you could also use the corollary to do this, and it would save you a little bit of time. But for me, I just kind of go about this way because the algebra to me is not the confusing part. 90 plus x plus, you need to distribute. So 2x plus 60 equals 180. Combine like terms, x plus 2x. Because the x's are both on the left side, you add them and get 3x. And because the 90 and the 60 are both on the left side of the equal sign, you add those to get 150. Equals 180. Subtract the 150 from both sides. 3x equals 30. Divide by 3. And x equals 10. Now it does say find the measure of each acute angle. So one of them is 10. The other one you need to plug it in. 2 times 10 plus 30. That's 2 times 40, which is 80. So one angle is 10 and one angle is 80. And I do want to give you one more example here, because you'll see this sort of thing. I'm not going to solve it all the way through, but I want you to see kind of what it would set up as. If this were 8x, this were 4x, and this was 6x. And I asked you to solve for x, or for that matter, to find the angle measures. So notice all three of these are inside the triangle, and we know, triangle sum theorem, the inside angles add up to 180. Inside angles add up to 180. All three of these are inside, so you take them and you add them and equal it to 180. This is 18x equals 180, and you get x equals 10. If you needed to know the actual angles, you can go back and plug them in. Otherwise, you would just leave it x equals 10. This should be enough information to go ahead and do your homework for 5.1.